Now we're going to move on to the root test. So if you're trying to determine if a series will converge or if it will diverge, with the root test, what you do is you mindlessly compute this value here. So take the nth root as n heads towards infinity. So with the root test, what you do is you mindlessly compute this value. If the limit is less than 1, then the original series, that's this original series, will converge. And if the limit is bigger than 1, then the original series will diverge. If the limit is equal to 1, then it's inconclusive. So let me give you an example. So we are trying to determine if this series will converge or if it will diverge. So with the root test, we just mindlessly try to find out this value here. So look at this. We've got you need to take the nth root as n heads towards infinity. If you look at this thing here, if you take the nth root of this, then it's going to be this times this. It becomes easier. So by glancing at this, you in the future you need to develop a hunch that you should use the root test, because with the root test you need to compute this 1 over n thing. So when you get this times this, it becomes easier. So over time, you need to develop a hunch. Over time, hopefully you develop a hunch that will tell you to use the root test. So with the root test, we need to mindlessly compute this value here. So this here is your an. So that's this whole thing here. And then we need to take the absolute sign. We need to take the absolute value here. And then your 1 over n, your 1 over n. So now that we're here, have a quick glance. N is moving from 1 to infinity. So as n moves from 1 to infinity, it will never be negative. So we can discard the we can discard the absolute sign. So from here, that will then take us to here. So remember, when you're here, remember that x to the power of a to the power of b, that equals a times b. So that would be a times b. So merge the two together, it becomes simpler. So it becomes this. Now, when you get to this stage, I've always asked you to ingrain this in your mind. You have to know this. You have to know this. Ingrain this in your mind. The limit of 1 plus 1 over n to the power of n as n heads to infinity is e. It is the number e. You have to ingrain this in your mind. You have to know this by heart. And then also, if you have, let's say, a number x here, let's say if you have a number a here, then it would be e to the power of a. If you have, I don't know, a 7 here, then it will be e to the power of 7. So you should have this ingrained in your mind, and this is what I've been trying to explain. If you have an x here, then it should be to the power of x. It should be to the power of x. Okay, you have to ingrain this in your mind. Okay, so when you're when you're here, you should have this ingrained in your mind. But then if you look at this number is 3. So what we do is we need to push this negative into the bubble here. So it will become, so we need to push a negative into here, so that will then become this. So now you've got your 1, and then you've got your plus, and this bubble here is really -3. So that's this -3 here. So it basically becomes e to the power of -3. Or e to the power of -3, it is this. And this number here, we know is going to be less than 1, because 2.7 times by itself 3 times. Well, this whole thing here will be less than 1. So we were trying to determine if this series will converge or if it will diverge. We would glance at this and then notice that if we take the nth root, this thing here times this, it will become easier. So we would use the root test. So when it comes to the root test, we need to compute this value here. Well, this value here, we've done it, and it came to 1 over e to the power of 3. So this is our capital L. This is our limit here. This here is our limit. This here is our limit. Okay. Well, our limit here is less than 1. So our limit here is less than 1. So therefore, the original series will converge. So therefore, our original series will converge. Okay.